Okay, so in previous videos, our random variable has already been standardized, but it makes sense that typically you'll come across variables that are not standardized. So how do we calculate the probability for those? Well, if we can standardize them, then we can calculate the probabilities because we've already learned how to calculate probabilities given standardized variables. So how do you convert to the standard normal random variable? How would you convert that? Just using the z-score, which we've already learned about this semester. So z equals x minus mu divided by the standard deviation. So how do we interpret this? Z is just equal to the number of standard deviations that the normal random variable x is from its mean. Right, so that makes sense. So it's basically saying that, okay, how far away is your variable x from the mean in terms of standard deviations? How many standard deviations away from the mean is it? So let's look at an example to make sense of this. So let's say that the time needed to complete a final exam in a particular college course is normally distributed with a mean of 80 minutes and a standard deviation of 10 minutes. Answer the following questions. Okay, so we have the mean is 80 minutes and we have the standard deviation is 10 minutes. But nowhere does this say that this is standardized or anything like that. It just says that it is normally distributed. So at least we know we're working with the normal distribution. So what is the probability of completing the exam in 1 hour or less? Okay, well, first of all, the first thing you should notice is the information was given in minutes, and now we're asked for something in an hour. So just make sure that you're always using the same units. So this should be 60 minutes or less, because 60 minutes is the same as 1 hour. So that's what we want to solve. What is the probability of completing the exam in 60 minutes or less? So down here is A. I said, what is the probability, right, of completing it in less than 60 minutes, right, in 60 minutes or less. So that's what that equals right there. I put it as Z because we're going to standardize it. So how do we standardize it, right? How do we put it into a Z-score? The value x minus the mean divided by the standard deviation. Well, x is what we're interested in, 60. Mu, the mean, we're already given is 80 minutes up here. And then the standard deviation sigma is 10 minutes right there, so you can just plug that in and solve. And so it's anything at -2 standard deviations, so 2 standard deviations below the mean. So I drew a figure down here. If this is our normal distribution, this is our mean, right? 2 standard deviations, it's down here. So it's asking for that it's less than or equal to. So we can just plug that into our norm.s distribution, which we've already learned so far, right? Plug in -2, cumulative is true, and we should get that 0.0228 if you round up. So that is the probability of completing the exam in 1 hour or less. Okay, so then the next question is, what is the probability this student will complete the exam in more than 60 minutes but less than 75 minutes? Okay, so this is one of those examples, right? Remember when we were learning about how to calculate probabilities, we learned, how to create something that's less than, something that's greater than, or something that's between two values. This is the example where we're looking at between two values, right? So we got that the student will complete the exam in more than 60 minutes, right? So more than, technically that should just be greater than, not greater than or equal to, but it's actually irrelevant. And then 75, but less than 70 minutes. So Z is less than 75 minutes. So again, this should just be less than, not less than or equal to. But remember, the reason why it's really isn't a big deal is because we're saying that Z is less than or equal to 75. Well, remember, with continuous probability, the probability of one particular value is 0. So technically, we're not changing anything because we'd just be adding that probability, which is 0. So it's not significant. It doesn't affect our answers at all. But you should be correct. You should write less than or greater than. And if it doesn't say in that value, you shouldn't include the bar underneath. But it's good to have that conversation anyways, just so you understand that concept. Okay, so we've already calculated this right up here, this part right here, that Z is greater than or equal to 60. We already calculated that up there. So now we just got to do this other part, right, so that it's less than or equal to 75. We have to standardize that. So again, 75, plug that in for X. mu is 80, sigma is 10, it gets to be, our answer is as negative 0.5 standard deviation. So let's plot this. We want to know, right, that it is, right, greater than or equal to 60, which is 2 standard deviations away from the mean, right, but it's below. So I'm trying to draw this out to make sense of what we have to do. Right, so this one we've already calculated, right, the probability that z is greater than 60. So where is that? Right, that's over here, negative 2 standard deviations, and then we have negative 0.5 standard deviations, that's right here. So what we can do is we can take, right, because negative 0.5, if we calculate that, that would be this whole area, not just this yellow area, but also this blue area as well. And then for negative 2 standard deviations, right, we've already calculated that z is less than or equal to 60, right, that would be this value in the tail. Well, we can just subtract that from this whole value, and we'd be left over with this area. So that's what we're going to do. So if we use the norm.s distribution, right, to calculate the negative 0.5, this value right here, right, we get the probability is 0.3085 and some change, right, so that's the probability that z is less than or equal to, right, so less than or equal to over here, negative 0.5 standard deviation. So that's this entire area. So we have to take that value, right, this value right here, and then what we're going to do is we're going to subtract this value right here, the 2, from that. Right, so this value right here, we can take that and then subtract this from it to get 0.2857. So let's just do that in Excel because I just did a lot of pointing just to make sense of this. So it's up here, so I've already done it for you. But just to make it clear what we're doing, let's just type it in, norm.s.distribution. Right, what do we have for our z-score is negative 2, cumulative is true, right, and we get this value here that we did before. Let's do it again for our other value, our other z-score, which is negative 0.5. Again, cumulative is true, right, and so what do we want to do? We want to subtract, let's look at our picture, we want to subtract this value here, right, the negative 2 from the negative 5. So we want to subtract the negative 2 from the negative 5. So we're subtracting this from this, and we get 0.2858 with rounding. So that's how you find the area between. So we've already done this, right? We've already learned how to do this, how to calculate the area between, greater than, less than, but now we're just applying it to situations where things are not standardized, and we have to do that step before we can use the norm.s distribution. So let's do one more problem, or the last letter in this problem. Assume that the class has 60 students, and that the exam period is 90 minutes in length. How many students do you expect will be unable to complete the exam in the allotted time? Okay, so we have to know that, okay, that 90 minutes is the maximum time that you have to take the exam. So anything that's above 90 is greater than 90 minutes. That would be the probability, right, that people don't complete the exam. So we can take that probability and multiply it by the 60 students to figure out approximately how many students cannot finish the exam. So again, we want to look at how many people will not complete the exam. So anyone who takes longer than 90 minutes, right? Because once you hit 90 minutes, you're done. So that's basically, we have to standardize 90. So, right, x minus mu, 90 minus 80 divided by 10 is plus 1. So 1 standard deviation above the mean. Now remember, this is greater than. So when we have greater than, what we can do, right, because the entire area under the curve is 1, is we can find this entire area, right, and then subtract that from 1 to give us this little leftover area in this tail. So that's exactly what we do, right? Norm.s distribution, 1, that's our z-score, cumulative is true, and then we take whatever that value is and we subtract it from 1 to get our probability. So our probability ends up being 0.1587 with rounding, right? So there's about 16%, probability that you're not going to finish the exam. So then we have to multiply that times our 60 to find out about how many students won't finish the exam. And it's about 9.5. So 9 or 10 students won't finish it. So let's do this in Excel. Right, it's already down here. I've already done this. So norm.s.distribution, z-score is 1, cumulative is true. Right, and so that, again, that value right there is giving us the area under this curve up until 1 standard deviation, but we don't want that. We want this area here, so we subtract this area from 1, which will give us this remaining yellow area, so equals 1 minus that area we just calculated. Right, so that's the area under the curve, about 16 in there, 0.16. And then we're going to take that value, right, and we're going to multiply it by our 60 students, because we know that there are 60 students in the class, and if about 15–16% of them don't finish on time, right, how do we do that, right? Just 16% of students of means multiply, so that's exactly what we do. We did 16% of the class, 16% times by 60 students will get us this answer. So it's about 9 or 10 students will not complete the exam in the allotted time.